Yesterday, we started with networking in Google Cloud, and I explained how Google provides a global networking solution to its customers and how Google Network provides connectivity to various services and applications that you deploy in Google Cloud. What virtual private cloud is, which basically provides you an isolated network in Google Cloud. And this isolated network can expand across multiple geographies and regions in Google Cloud. So you have your own isolated network, which you will leverage to deploy workloads and applications. And those workloads and applications can be hosted across the globe, across multiple regions and locations of Google Cloud, and they will all be able to communicate with one another over a private network, over private IPs. However, if you have two networks, then the communication between resources across the networks will happen over external IPs, which is public IPs. We also looked at why do we need to segment the network so that when we have an application which is a multi-tier application, or when we have multiple applications in a corporate environment which has their own security requirements, we can have them placed or hosted across subnets so that we can apply security controls or firewall rules in the language of Google Cloud accordingly. We also call them access control list. We also looked at best practices in Google Cloud, which is we should start small and expand when needed. And also this is common for all the clouds. When you bring data into cloud, there is no charge for it. You only pay for the storage cost. So if you have 1 TB of data, or let's say hundreds of terabytes of data that you want to store in Google Cloud, since you're migrating to Google Cloud, you also want to migrate your data. You can bring that data into Google Cloud, upload that data, use Google Cloud, Snowball service, which is a physical data transfer service. Snowball is definitely paid, but for uploading data into Google Cloud, there is no charge for it. So you can bring as much data as you need in Google Cloud, in any cloud. There is no charge for it. But when you download the data, or when you copy the data from one region to another within the same VPC, across VPC, you will be charged accordingly. And for that, I showed you this presentation, the last slides of the presentation, which talks about the charges, which is here. Over here. So you can see ingress, there is no charge, but for egress means outbound transfer, outbound traffic. It could be a copy operation, it could be a file transfer operation, it could be some read write operations. So there are charges for outbound traffic, but when it comes to outbound to Google products, which is YouTube, Maps, Google Drive, there is no charges. However, when you are doing outbound traffic between zones in the same region, there is some charge. Uh, Same zone with external IP address, there is some charge. So basically, in a nutshell, there's a charge for outbound and there is no charge for inbound. That's that's how cloud service providers operate. And then I asked you all to have your lab environment ready to have created a free trial account so that we can practice labs today. So we have done that. We have covered the theoretical aspects of VPC service yesterday in detail. We spent an entire 2 hours discussing about VPC. Today, we will focus on hands-on around VPC. So we are going to provision VPC. We're going to see what all building blocks and components we get to configure while provisioning a VPC, and and how do we and what are the options, how many types of VPCs are there, and how do we configure them all, and how this VPC will help you to host resources in the long run. That's what we're going to look at. So let us switch to our lab environment, all of you. So I already have logged into my Google Cloud project. I have created a project with the name Nextern. All the provisioning that we need to do, I will be doing in this project only. So Let us all sign in to your respective Google Cloud project or Google Cloud console and select the project of your choice where you want to build and deploy resources. Yesterday, as I talked about that we have three types of VPCs in Google Cloud. Type of VPC. The first type is default VPC. Then you have auto mode, and then you have custom mode. These are the three types of VPCs in Google Cloud. Now, the default VPC is created when you create a project. It is by default gets created, and this VPC has one subnet in each region of Google Cloud. So let's look at this project. So what I did, I created this project today. Is my screen visible to everyone? The console?
Yes, yes.
Okay. So what I did today, I created this project. When I created this project, after this project was created, I signed up. I basically navigated to this project. I selected this project and I navigated to, I'm saying this is these three horizontal lines. This is your navigation menu. When you click on these three horizontal lines, you can navigate to any service that Google Cloud offers or which is part of this project. So the service that is of our interest today is VPC Networks. And under VPC Networks, we need to click on VPC Networks. So there are multiple options here. Our interest is VPC Network. So when we click on VPC Networks, it basically takes us to the VPC dashboard where you see all the VPC networks or all VPCs that you have in Google Cloud. So if you notice here, we have a default, we have a VPC network with the name default. It is already created. It's created by default. And let's look at its configuration. So if we look at from here, you can see the name of this network is default. Can I change the name? No, I will not be able to change this name. How many subnets are there? 41. What is the MTU? This is the property of that VPC, maximum transmission unit, which basically means that how much data can be transferred, using this VPC, per minute, per, second basis. Then comes mode. Mode is auto mode. So if you remember yesterday, I told you that there is no difference between default and auto mode VPC, except the fact that auto mode VPC subnet range can be expanded from /20 to /16. That's the only difference. Rest of the configuration is same because your default VPC also uses auto mode option. IPv6, it is not taken by default. There is no gateway. There are 4 firewall rules and global dynamic routing is off. Now let's click on this VPC and let's go inside and see the components. So when you click on a service name, it takes you to that service blade and you see all the properties of the service. So if I click on overview, it says edit. What can I edit here? So can I edit the name? No, that option is not there. All I can edit is whether I want a subnet creation to custom. It says switching from auto subnet to custom subnet. VPC network allows you to manually define subnet prefixes. So basically I can convert that into a custom mode VPC. I can change the routing mode. Routing mode basically means regional, basically means that cloud routers which Google uses or which are there on the internet will learn routes only in the region in which they were created. And global basically means global routing lets you dynamically learn routes to and from all regions with a single VPN, interconnect or cloud router. So routing basically means that the router that Google uses to route your traffic from source to destination, whether you want regional routing or global routing. Now you should go with regional routing because that is quick. If you go with global routing, there will be multiple routers that gets involved, and it may take time for your traffic to reach from source to destination. However, this also has a benefit. The benefit is that because of this global routing, your DNS resolution will be quick. So this has its own pros and cons, but by default, we go with regional routing. Okay, then comes, you can also add tags. Tags are key value pairs that helps you to identify a resource. So you can add tags here. So we'll talk about tags later on. Let's move on. Then comes subnet. So you will need to cancel this first. Then comes subnets. Now here you see that we have a lot of subnets. We have one subnet in each region, and the subnet name for all the subnet is default. However, you will find one region. So one subnet in each region, and it has a pre-configured IP address range also. Can I change this range? No, there is no edit button here. This range is fixed. However, this range provides you 4,096 IP addresses. This range basically provides, which is more than sufficient. So you can see that there is one subnet in each region here. And then you see the gateway also for each. Gateway basically means that whenever there are resources in this subnet, when they send an outbound traffic, what is my first hop? What is the first service that will receive the traffic? So that is known as gateway. So this is the gateway IP of it. In fact, on your laptop, if you do CMD, if you open command prompt and if you type ipconfig in the command prompt, you will see the gateway information. So if I type ipconfig, I see the gateway information. Now this is the IP address that I'm getting. Right now I've connected a LAN port, a LAN cable. So this is the information here. You can see my IP address that my system is receiving is this. And this is my gateway, default gateway, which is 192.168.1.1. Now this 192.168.1.1 is the IP address of my router to which my LAN cable is connected. So when I send an outbound traffic from this system, the first hop will be the router. So for example, you can check it. We can run this command, which is tracer www.google.com. If I say that, tell me, if you want to check that when you type a resource address, resource or domain name in the web browser, how the traffic propagates, how it reaches to the destination, and what are different hops in between. So if I type and hit enter, you will start to see that there will be a maximum of 30 hops that it will show you. And the first hop, you can see so either I type this www.google.com in the web browser, or either I type it here. The first hop is going to be this router 192.168.1.1, and that's my default gateway. So same concept you have here in Google, that each resource will be provided an IP address from this range, depending on the subnet that they are part of. And the default gateway of that resource is going to be this IP. So the first hop is going to be this IP. That's the concept of gateway here. Okay, then comes static internal IP addresses. This basically shows you if you have any static internal IP addresses. You will need to allocate these IP addresses. They are not available by default. Similarly, each VPC has a firewall. It is a global firewall, which is controlling the traffic to the VPC irrespective of the subnet. So this firewall is the first hop that will receive the traffic. I'm saying if the traffic is coming from outside world, then it has to go through this firewall before it reaches the resource, reaches the virtual machine, a compute engine instance. Or if you are sending the traffic to the outside world, this will be the last hop before that traffic leaves your network. Before the traffic leaves your VPC, it has to go through the firewall, and firewall will decide whether that traffic is allowed or denied. By default, firewall is configured to deny all incoming traffic and allow all outbound traffic. That's the default behavior of the firewall. It denies all incoming traffic and it allows all outbound traffic, outbound to internet or outbound to the same VPC. So that's what your firewall is. If you look at the firewall rules, you will see some rules here in the firewall, right? Now look at these rules carefully, what it says. My first rule is default allow RDP. What does this mean? This basically means that it's an inbound traffic ingress firewall rule. It is for global rule. The rule priority is this, and the target. Who does it apply to? Apply to all. It says this rule applies to all the targets in this VPC. And what is the source? Source is internet. What is the destination? Destination field is blank. Why it is blank? Because it applies to all. So what it tries to say that from anybody from this source IP, this is 0.0.0/0, which means internet. Anybody with any public IP from anywhere in this world is able to send RDP traffic to a resource which is part of this VPC. Because the target is applied to all. It applies to everyone. And the protocol for RDP is TCP 3389. Action is allowed. So it basically means that the inbound traffic on TCP IP port 3389, which is remote desktop protocol, is allowed from the internet. So these rules are default rules. Similarly, there is a default allow SSH, which has the same behavior. It applies to all targets. The source is internet. Port is 22, which is the SSH port. And with this port, an action is allowed, which means all inbound from internet, all inbound traffic from internet on port 3389 and port 22 is allowed. And why this default rule? This default rule is there so that you yourself can connect to your VMs. Now, it may not happen that from day one, you will have a VPN configured from your on-premises network to Google Cloud. Probably you have just started using Google Cloud and you are in the process of evaluating the services. You have not yet decided that you would want to go with Google Cloud, and hence you have not created any private tunnel, a VPN. So these rules will basically allow you to connect and communicate with your resources. Then we have another rule, the third rule. However, since they are default rules, you can delete them also. Then comes the third rule, which is default allow internal. What does this tool rule means? It says internal traffic, rule priority is this, and it says apply to all. The targets are applied to all. It says IP range is this. So the IP range is 10.128.0.0/9. This is your VPC address space actually. The VPC that you are in, which is the default VPC. This is the address space of the VPC, and all the VPC subnetworks are contained in this address space. So what it says is that if there is a traffic from this source, destination is blank. Blank means any destination on any of these port, whether it's TCP IP, whether it is UDP, whether it is ICMP. Please allow it. So what this says basically that all internal traffic within the VPC is by default allowed on all the ports. Then we have a separate ICMP rule. ICMP stands for Internet Control Messaging Protocol, which is for ping. When you perform a ping, when you put a ping command, that's what ICMP is. So here, if I open, let's say the command prompt once again, and if I say ping www.google.com, what I'm doing at this moment, I'm sending ICMP traffic to this website. And you can see I'm getting the response, which means google.com is available. And it also resolves while you send ICMP traffic, it also does DNS resolution. I can also see the IP address of google.com. But Google has multiple servers in the world, almost in every nook and corner of this world. So it is not guaranteed that next time when I do google.com, I will connect to the same server. Probably the server will change. This may also happen. So this is known as ICMP traffic. So this ICMP traffic is allowed, you can see, from internet. The source is once again internet, and it is applies to all, and it's ICMP allow, action is allowed, and it's ingress traffic, internal traffic. So we have 4 default VPC rules, one for RDP, one for SSH, one for ICMP, and all 3 are from internet. And then we have one more rule that allows all the traffic internal, all internal traffic, from source to destination within the VPC. These are the 4 default firewall rules that you will find when you provision your first VPC. And then you will have an option to either choose them or ignore them. That's your choice. So I see a participant raising hand, which is Madan. Yes, Madan.
Yeah. Yeah. Hi, Raghav. So I just want to understand, is this firewall, is it something like in AWS NACL is there, right? Is it something like
Uh,
NACL or is it
not
security group?
exactly. This is NACL. AWS has 2 virtual firewalls, right? I'm saying you
Mhm.
guys are lucky that I was delivering another AWS training today itself. So I probably have it opened, the console. Yep, it's open here.
And so what is this priority? Is the priority also can be
I'll
changed?
talk about it. So
Yeah.
AWS VPC has 2 types of firewalls. One is NACL, the other is security group. Now, NACL is at the subnet level, which basically means all the traffic that is destined for your VPC, whether inbound and outbound, has to pass through this NACL. After it is done passing through the NACL, then it will reach to the resource. Right before it hits the resource, which is your EC2 instance, it has another layer of security that it has to pass through, which is security group. So you have 2 security layers, NACL, which is at the subnet layer, security group, which is at the instance layer. So collectively, NACL and security group is your firewall in GCP. That's how it is, right? So NACL and security group collectively is equivalent to firewall service in GCP, because in GCP, you don't have a firewall which is front-ending the compute engine instance. It is the VPC that will be configured to either allow or deny traffic to your VPC, which includes all the resources inside the VPC. Now, to answer your second question, which is what is this priority? It is the same concept everywhere. Lower is the priority, highest is the precedence. That is why the priority of these rules is the highest. You can see 65,534, 65,534. Why? Because that's the highest number. Now, any custom firewall rule that you will create, you will choose a priority lower than this. And the moment you create a firewall rule with a lower priority, and if it has the same behavior, then the one with lower priority will take precedence. So if you don't want to delete these rules, you want to keep them, but you want to create an exception for a specific set of compute engine instances or for the entire VPC. Let's say you don't want to allow RDP traffic for now. So what you will do, you will add another firewall rule with a lower priority with the same configuration and action as deny. And that way you will have 2 firewall rules with the same configuration, but they differ in action. One says allow, the other says deny. Now the question is, which will take priority? Whether allow will take priority or deny will take priority, it will be decided from the rule priority, which is the priority number. So whichever rule has low priority number, it will take precedence. That's the concept of priority here, which is the same in AWS and Azure. Hope that answers your question.
Yes, yes. Thank you.
Great. Let's move on. So that's my default firewall rules. I can add more rules and I can also remove the existing one. That's very much possible here. But since this is default VPC, I'm not gonna touch it. I'm not gonna modify its configuration. I leave it as it is. I will probably create my own custom VPC. That's where I will do all the experiments. I'm just explaining this VPC so that you understand the concept of default VPC, because the other VPCs that you will create, they will also have similar components. Then comes firewall endpoint. So here you can see firewall has I'm saying firewall endpoint is not enabled, and endpoint we basically use to restrict the traffic. Then you see firewall routes. Route basically means any specific routes that you want to create. Now, right now it says no route to display. You can see all the routes, or you can select a specific region and you will see the routes of that region, that what all routes are here. So you will see that it has a route for each. I say from that region to all the other region, there is a route, which basically means that all the traffic within the VPC is whitelisted. It is available. That's what it says. So here you see the destination IP range. This destination IP range uh, denotes to all the other VPC. And in fact, you can see a destination route for internet also. So because of these routes, and you can see the next hop, I'd say it says, understand this. It says that if there is any traffic which is destined to this range, this is a local range, private IP address range. If there is any traffic which is destined to this range, what is my next hop? Next hop is virtual network, which basically means that the target is available in the network itself. It's a local server, it's a local machine, it's a local server, it's a local compute engine or local resource. But when you say that the destination is internet, then you will notice that it says default internet gateway. It is the same AWS concept where public subnet instances can communicate to public internet and are also accessible from public internet. And the default gateway or internet gateway is the service that basically allows internet communication. So same concept here in GCP, you have internet gateway. Now, GCP was launched in 2012, or let's say 2014, full-fledged. AWS in 2006 and Azure in 2010. So definitely when GCP has built its cloud services, the GCP has taken a lot of knowledge and experience from AWS and Azure collectively. It has looked into all the shortcomings, drawbacks, weaknesses of Azure and AWS and tried to address it in its cloud. And it has also taken into consideration the service nomenclature, service component, service configuration, and tried to keep it as similar as possible. However, not violating any copyright. So they cannot put it exactly the replica of it, but they try to keep it as similar as possible so that resources from other clouds can quickly pick up Google Cloud and quickly get the applications and workloads onboarded into it. That's the reason. So you will see this behavior here. Then you can see VPC network peering. Peering basically means connecting two VPCs for the purpose of enabling communication. Next is private service access. Private service access basically means that with this private service access, it says use private service access to connect to specific Google and third-party services without assigning external IP addresses to your Google Cloud and Google Cloud third-party resources. So private service access basically means that if there is a resource in Google Cloud which doesn't have a public IP, but that resource wants to communicate or access any Google Cloud service which is available on the internet or which is part of Google Cloud network. So for example, YouTube is available on internet. It is outside of Google Cloud, but it's a Google product. Similarly, Cloud Storage Bucket is part of Google Cloud. It is within Google Cloud network, and it is also a Google product. So with private Google access, you will be able to access the Google Cloud products. So it says use private service access to connect to specific Google and third-party services without assigning external IP addresses to your Google Cloud and Google or third-party resources. That's the benefit. It says private service access requires you to first allocate to an internal IPv4 address range and then create a private connection for it. So that's private service access. So these are my components of default VPC. Now what we are going to do, we are going to deploy the remaining two VPCs, which is custom mode and auto mode VPC. And then we will notice if there is any difference in the configuration. So let's get started. We will first deploy an auto mode VPC. So how do we provision an auto mode VPC? You will click on create VPC network. Here you will need to provide the name of the VPC. So I can say testing auto mode VPC. Now, remember one thing, Google doesn't allow you to use uppercase letters. You will always use lowercase letters while providing name to a service. Also, it doesn't allow underscore. It only allows hyphen. So if I choose underscore, it will say that name must be lowercase letters, numbers, and hyphens. So I cannot use underscore. So I've given the name of the VPC, then it says description. I'll put the same name as description also. Then MTU is 460. You can read here what it is. It says MTU is the size in bytes of the largest packet supported by a network layer protocol. So when you are sending the traffic or receiving the traffic, the packet is nothing but your traffic. The size of that traffic will not go beyond 1460 bytes. 1460 byte, that's MTUS. Then it says VPC network internal IPv6 range. Do you need IPv6? If yes, click yes. Otherwise, it is by default disabled. Subnets. Now this is where you will provide the subnet information. But before you provide, you need to select the creation mode. So if I say it's automatic, then it will. So since I'm creating an automatic VPC, auto mode VPC, I'll select automatic. The moment I select automatic, you will notice that it has already identified the IP address range for each region. So what it is going to do, it is going to create one subnet in each region with a predefined IP address range. I don't have an option to change it. It says these IP addresses range will be assigned to each region in your VPC network. When an instance is created for your VPC network, it will be assigned an IP address from the appropriate region's address range. So if you create an instance in Asia -East 1, the instance will get an IP address from this range. Then firewall rules. Now you see all the same firewall rules here with two additional rules which are for deny also. So you can pick and choose the rule that you want. For example, I want to allow ICMP ping. I want to allow TCP and SSH and RDP. And I also want to allow internal communication. If you don't want to allow internal communication, don't choose this rule. But you must choose this rule because if resources can't communicate internally, then what is the point of putting them together in the same VPC? Then dynamic routing mode, same regional global, we'll go with regional. And then we can create it. So that's how we create an auto mode VPC.
Oh, you created auto mode?
Yeah, that's auto mode.
Okay.
So let it get created, then you will see all the information. So first we'll create an auto mode, then we'll create custom mode. Custom mode will take more time, hence we will create it in the end.
So in automation, like what about the subnet allocation? It will be automatically created.
It's automatically created.
Okay. And one more thing I need to ask regarding that firewall. Like in GCP, it will works at instance level or VPC level.
That's what I was just explaining. That your firewall, you have one firewall which acts at a VPC level to which all the resources adhere to. So we cannot say that it's an instance level firewall or VPC level firewall. It's just one firewall that is at the VPC that gets configured along with the VPC, and all traffic to your instances, whether inbound or outbound, must pass through this firewall. That's the concept.
Okay. So like
Right?
there are 5 instances. Like can I configure each firewall for say a specific instance?
No, you will. So you will not configure the firewall. You will create rules in the firewall.
Okay.
So you will create a rule in the firewall, and while you create a rule, you can select a specific target. Let's say I'm creating a rule for a specific server. Then in the destination, I will select the IP address of that server. And then that rule will only apply to that server. That's what you can do. So
Okay,
you
okay,
can create a blanket block rule and then create an exception to a specific server by allowing that traffic. That's how it happens. So when we do it, you will understand it. Now our auto mode VPC is created. You can see
Yeah.
it has
So
40
Raghu,
subnets.
one question,
Yes.
Raghu. See,
Hmm.
when we create auto mode, is there a way like we choose private and public subnet kind of thing? Is it
No,
possible?
no. For that, you have custom mode. That's the next VPC that we are going to create, wherein you will choose everything.
Okay, right.
Auto mode is equivalent to default with the difference that here you can change the subnet range, subnet address space from /20 to /60. That's the only difference. Rest of
Okay.
the configuration is same. You can see there. However, in auto mode, you only see 40 regions because probably one of the region is not available. MTU is 60, mode is auto. Default is also auto mode and auto mode is auto mode. For firewall rules and global dynamic routing is off. Is everyone with me on this? Let's just go ahead and provision a default, provision an auto mode VPC. Then I will show you how do we provision a custom mode VPC also.
Yeah, it is same like in subnet, right? Each subnet will be using 5 IP addresses internally for the communication, everything like AWS.
No, that's not the case that you will see here,
Okay.
that how GCP works. So
Okay.
that's while you're trying to learn GCP, you are allowed to compare and correlate, but at the same time, do not over compare and correlate that you will lose. You will not be able to understand this cloud. Sometimes you need to learn from us fresh so that you understand what this cloud is, then do the comparison and correlation, right? Since I
Got it.
work with all the three clouds, I can right away answer this question, but that will not help you. So you will probably see it from your own eyes and then you got to believe it and you will not leave it forever. For example, in Azure, the 5 IPs, the first 4 and last IP is reserved. In AWS, it is not the same behavior. In Azure, IP addresses are allocated in sequence, in the sequential order. It will start with IP4, 5, 6, 7, 8. In AWS, it is allocated on random order. So it is good to have knowledge of the other cloud and then compare and correlate, but do it after you understand this service. Then do compare and correlate, not while you are trying to understand the service. Otherwise, it will break the flow of yours and you will have gap in your knowledge. So we will first understand the service. Once we are done, then I will be open to questions. Definitely, I may not be able to answer all your questions then and there. If not, then I'll get back to you. But majority of your questions I can answer because I have been working with all the three clouds for a long time, and I've delivered a lot of training so far in the past that there is absolutely nothing that I may not be aware of. Or if there is anything that is changing, then it is a surprise for all of us together because cloud is very dynamic. Okay, so let's move on to the third part, which is the most important part, which is the custom VPC. So let's create another VPC. Now, while we are creating this VPC, so default VPC means pre-configured VPC in each project. That's default VPC. In each project, you will have a pre-configured VPC. It's default VPC. Auto mode VPC. It is also like a default VPC. However, subnet address space can be expanded to /60. That's the only difference. And custom mode VPC is your actual production VPC. Actual production VPC for hosting resources and services. So this is the VPC that you will create for hosting resources and services. Now, why you should not use auto mode VPC? Understand this. My auto mode VPC has 40 subnets. And when I go to those subnets, I will find one subnet in each region across the world, in all the Google regions. Now you also know by design, if I have a resource here in this subnet Australia, over here, this resource can easily communicate with this resource in US. Now I don't have any business in Australia, but even though I have a subnet in Australia, so my attack surface area is larger now. Some hacker can provision a resource in Australia which may go unnoticed from my eyes because I don't bother about Australia. I don't have any customer there. I don't have any resources configured there. And then the hacker will use that resource to communicate over the network to other resources also. So using an auto mode VPC is like increasing your attack surface area. The attack may happen from anywhere. That is why we go with custom VPC, wherein we will create subnet based on our requirements. So if I only have business in Europe, US, and Asia Pacific, I will only create VPCs there. Why would I create subnets everywhere when I don't need them? This is like you have a lot of money and then you purchase a house in every country of the world. Great. You have money, you can do that. What is the point of doing it? You can only stay at one place at a time. So you are unnecessarily wasting resources in maintaining those houses. And you are increasing your attack surface area at the same time. So we'll create a custom VPC now. Let's understand it. So we'll first give it a name. I will say testing custom VPC. Description, I'll put it the same. Now here, MTU remains the same. You can increase or decrease it. We always go with 4060, which is the best practice or default number. Then subnets. Now over here, the moment I choose custom, if I choose automatic, then it will automatically create subnets. But if I choose custom, it will say I'm not doing anything. You decide what you need to do. You decide how many subnets you want to provision, in which region you want to provision, what kind of properties you want to give to those subnets. So the moment I've selected custom, it says new subnet and add subnet. So it is asking me to add a subnet. Now I'll click on add subnet. When I click on add subnet, I will add a subnet based on my requirement. Let's say I have business in US and I want to deploy some resources in US. I want to deploy some compute engine instances, cloud storage buckets, Google Kubernetes engine, clusters, or or other services of Google Cloud Run and other services, or Cloud SQL databases, BigQuery. I want to use. So I will create a subnet. So I can say this is my production subnet. Production subnet. I will use definitely some East US, some nomenclature that a business uses. Then the description I will put. Now here I will need to select the region where exactly I'm going to create this subnet. So I select the region, which is, let's say I want to create this subnet in US. I will select one of the US region, US East 1, which is North Virginia. Then the IP address tag is IPv6, then IP range. Now I have the capability to select the IP range here. I can select an IP range of my choice. Let's say I'll select 192.168.1.0/24, which is a class C private IP address range that gives me 256 IP addresses for this region. When I need more, I will create additional subnets, but I follow the policy of start small and expand. So I'm starting small. Then I can also create secondary IPv4 range. I'm saying if I feel that this one is not sufficient, I will create another subnet with, over here and create a secondary range. So let's leave that part right now. Then it says private Google access. Private Google access basically means that whether this subnet production subnet, whether the resources of this subnet, when you provision them, do you want them to have access to Google Cloud Services, Google Cloud Services, as well as other Google products, which is Google Drive, YouTube, or Google Cloud Services like Google Cloud Storage Bucket. So if you click here, it says set whether VMs in the subnet can access Google services without assigning external IP addresses. So you don't need to assign public IPs to those VMs. With this setting in place, private Google access turned on, those VMs will be able to access the Google Cloud services as well as other Google Cloud products. So I'll turn it on. Then says flow logs. Flow logs basically means the traffic that comes in and that goes out. Do you want to capture flow logs? That will help you in troubleshooting network security issues, security incidents. You can enable flow logs also. But when you enable flow logs, you need to configure it. So here you need to configure the flow logs that, OK, I want to enable flow logs and my aggregation interval. Aggregation interval basically means that the time duration within which the logs will be captured. So I can say my aggregation interval should be 10 minutes, which means every 10 minutes it will capture the logs. You cannot put it 5 seconds. The moment you put it 5 seconds, there will be a lot of logs. And since it uses a storage in the backend, you will unnecessarily pay a lot of money for the storage. So 10 minutes is the ideal duration that they typically go in production. Additional fields include metadata. Sample rate is sample rate 50%. And then hide logs configurations. We have selected the configuration for logs. Then we'll move on to the next, which is hybrid subnet. Now, what is this hybrid subnet? It says allowing hybrid subnet modifies the VPC routing behavior to allow overlap between the subnet IP addresses and those of custom dynamic routes. So with hybrid, you can allow IP address overlapping in the VPC subnets, but this is against the design. Don't do it. That is why it is by default turned off, because this may create issues in future when you go and create VPN tunnels. So let's turn it off. Now, this is one subnet that I have created. Do I want to create additional subnets? I can do that. I will say add subnet once again. I'll create one subnet in India also. So when you are creating the subnet, you can put some differentiation to differentiate them. So I can say production subnet APAC, Asia Pacific. Now you can create multiple subnets in the same region. It is not that you will only be able to create one subnet in East US 1. You can create one more. You can have additional subnets in other regions of US. There is no restriction here. So just to keep it simple, I'm creating one more subnet in APAC. I can select my APAC region, Asia South 1. IP address type is same, and here I can select another range also. So make sure that your IP address ranges are not conflicting. So here I can select 2.0/24. This one is 1.0. This one is 2.0. That's the difference. So it's a different range. Here I can choose not to enable private Google access, not to enable flow logs. That's all my choice. If I want to add one more, I can click on add subnet. You can keep on adding subnets. The higher limit is very high that you will not be able to reach it. So new subnet, I can say this is my production subnet, EMEA, Europe, Middle East, Africa. And I can create this subnet also. Select the region. This time I'll select Europe. Let's say Europe North 1. Select the range 192.168.3.0/24. This is how I can keep on adding subnets like this. So I've created 3 subnets, 3 production subnets, one in US, the other in Asia Pacific, and the third one in EMEA. Similarly, you can create non-production subnets, test subnets, dev subnets, multiple subnets here. OK, then comes firewall rule. Now you will notice one thing, that the more subnets that you will create, it will by default, firewall will by default be configured to allow all internal communication between those subnets, though they are across region, across thousands of miles away. One is in US, the other one is in India, the other one is in Europe. They are thousands of miles away. However, firewall is configured. Look at the first firewall rule. The firewall is configured to allow traffic, ingress traffic, ingress traffic to those subnets. And you can see all the three IP ranges here. To all ports and protocol, action is allowed priority 65,534. It allows to all target, which means any resource in any of these subnets can send traffic to other resource in these subnets. So internal communication is by default allowed in the firewall. You can always edit it also when you want, when you don't want US and Europe to communicate, but US and India to communicate. That is what you can also do by custom. So we'll just go with the default. Then you can see we also have ICMP, RDP and SSH rule. So we'll go with these rules because we need them. And the same concept, dynamic routing mode would be regional. That's it. And you can hit create. So this is how you create a custom board VPC. Now it says that some fields do not have information. For example, over here we get an error. It says new subnet. So probably I did not provide information here. So I'll delete it because I already have three subnets here. US East 1, Asia South 1, and Europe North 1. That's it. I'll hit create. And now this will create my custom VPC with the configuration that I have provided. This is just the starting point. If I ever feel that I need more subnets in an existing region or in a new region, I can always click on edit and add those subnets. If I feel I need to delete, I can also delete, provided there is no resource in those subnet or there is no resource to which an IP address from that subnet is allocated to. So I can do all the customization. That is why this type of VPC is known as custom VPC, that it is fully customized and it allows fully customization. So this VPC is getting created. We'll need to give it probably less than a minute for it to get created. Yep, you can ask questions meanwhile. Yes, Rakesh.
Yes, sir. Actually, here we are not giving the like VPC range. Like a subnet will be taking like his IP address from a VPC now, but here we are not giving any VPC range. We are directly giving the subnet ranges.
Absolutely. That's the reason we call Google VPC is a global VPC. It doesn't have its own range. That's the first thing that I talked about in the presentation when we started. Over here, it says a network has no IP address range. It is global and spans all available regions. It contains subnetworks, is available as default, auto or custom. So it doesn't have any range. That is why you have the freedom to pick and choose a range of your choice while you provision a subnet. Imagine if, similar to Azure and AWS, Google VPC had an IP address space, a range, then your subnets range must be contained in that VPC range. Yes. And that would have been a challenge or limitation. That is how Google has created a different VPC, not imitating what AWS and Azure does, thinking out of the box and then creating a separate arrangement altogether, which allows a customer to have very limited VPCs to host thousands of hundreds of thousands of resources. While in AWS, you know that resources are bound to a region. So you will provision a VPC in a region, and then you will host resources in that VPC from that region only. And that way you end up creating multiple VPCs in AWS. Same is the case with Azure. Azure also has a VPC bound to a region. But in Google, VPC is not bound to a region because VPC is global and subnets are regional, and each subnet can be configured within different IP address range. So for one subnet, I can use 10 series. For other subnet, I can use 172 series class B private IP address range. And for the another subnet, I can choose class C private IP address range. So Google Cloud VPC is much more advanced and allows for flexible configuration as compared to its counterpart in Azure and AWS. Hope that answers your question.
Yes, yes. Then we don't need to create multiple VPCs here. Only one is enough, and we can play with the subnets.
Absolutely. In fact, since VPC is part of a project, I'm saying here it is contained inside a project, the arrangement. So in Azure, you have a subscription. Inside the subscription, you create a virtual network. That virtual network is bound to a region. In AWS, you have an account. Inside that account, you choose a region and then you provision the service. However, in GCP, you have a project which is Nextern as we speak. The current project that I'm in is Nextern. Inside this project, I'm creating this VPC. And this VPC is global. It has subnets. Imagine it has subnets across the regions, which means inside this VPC, I can have resources hosted across multiple regions. But then the question is, what if I have another project which also has a VPC and that VPC also have the same behavior? It has subnets across the region and it has resources. So do I have an arrangement and that project belongs to some other department? Now, there could be a probability in Google Cloud that you will have allocated a separate project to each department for the purpose of billing and chargeback. Now, those departments will have their own VPCs and they will have their own configuration. And you want to centralize the management. You want to centralize IT management so that there is a centralized team who will define and who will enforce and who will manage all networking and security operations. So in that case, Google also provides you a service with the name shared VPC, wherein you can create a VPC in the host project. I'm saying you can create a VPC in one project, consider that project as host project, then you will have that VPC shared with other projects, which are known as service projects. So you also have this capability wherein with one VPC, you can manage your entire show in Google Cloud. You don't need to end up creating multiple VPCs the way it happens in Azure and AWS. So Google, when it comes to VPC service, is quite mature, refined, and global. All right, coming back to the custom VPC once again. Now that I have created a custom VPC, let's look at this VPC. So when I click on this VPC, I see my VPC configuration. I can always edit it. When I say edit, I can enable IPv6. I can change the routing mode from regional to global, and I can also attach tags. That's what I can do here. I'll cancel it. Then subnets. Only 3 subnets are there as we speak. It shows the region, IPv4 stack, the IP address range of those subnets, and you also see the gateway information of these subnets because they will have a gateway also, which is the first IP address is the gateway. Private Google access is on for one subnet only, which is production subnet, and for rest of them it is off. Flow logs is also on for the one subnet and rest of them it is off. Now, what if I need one more subnet? Let's say I start with this configuration for my customer and my customer comes back to me and say, you know what, I also need to test my application before I move it to production. And for that, I need a separate test network. I cannot test it in production network. So what I will do, I will ask them, okay, where exactly you need that subnet? They said that I need a non-production environment, non-production subnet in Asia Pacific. So what I'll do, I'll click on add subnet, select the name, which is non-prod or test, whatever you want to select, non-prod subnet, and I can select APAC. Create it, provide the description. VPC network is by default selected. Region I select, which is APAC South 1, because they already have production subnetwork in APAC South 1. Now I'm creating a non-production network that says purpose. What is the purpose of it? Here I can select that what is my purpose, whether I want to cross region manage proxy. Just leave these part. Let's just keep it simple. Purpose is none. Then IP stack type is IPv4. Here I can select the IP range. Now I can also select a separate range. Let's say I have decided that for my production networks, I will use class C private IP address range. And for my non-production networks, I will use class B IP address range or class A IP address range. That is also possible. So let's say I'll go with class A 10.1.1.0/16. It says this is incorrect. So probably 10.1.0. This is correct. So I can go with this range also. Now this will provide me many IP addresses. I want to keep it short. I'll say let's go with 24. So this will give me 256 IP addresses here. Then I can create a secondary IP address range also in this subnet. Private Google access for this, I will keep it on. Flow log, I will keep it disabled, no need, and I'll click on add. Now I have a fourth subnetwork or subnet in this VPC, which is in Asia South 1. However, it is using a different IP address range, and this is my non-production subnet. All right, it got created. You can see it's here. It has a different range, and this is the gateway for it. All the information you see here. So this is how you will keep on adding additional subnets to your VPC as and when the requirement is. That way, you are reducing your attack surface area because you are not unnecessarily expanding your network to a region where you are actually not hosting any services. But that region will act as a attack vector for you in future. So that's the concept. Flow log, I can view the flow log of all subnet. I can turn it off. I can configure. So leave that part. So this is how we add subnet. Then static internal IP addresses. I've not taken any firewalls. Here you see the firewall rule now. The same firewall rule will be there. There is one firewall rule you can see here. And now you will notice that I have one more subnet. So the common rule, which is allow all traffic, the custom one. This rule, if you see, it will have all the address spaces added here. You can see 1.0, 2.0, 3.0. So I'm saying you just need to refresh it and the other one will also come. It will come in some time. It is just a refresh. So that's how you will see the firewall rules also that it has created. Now the question is, how do we test it? I'm saying if I want to test something, I will need to provision resources here. But before you do that, let's just understand another thing, which is firewall endpoint, which is OK. Routes you can see. You just need to type the region and you will see the routes for it here. You don't do much configuration in the routes as long as you're not targeting for network specific certification exam in Google Cloud. VPC network peering is not enabled. Private service access is, you can enable it, but let's leave it. So what you need to understand. To summarize, you need to understand how do we create a VPC? What are my different types of VPCs that are available in Google Cloud? What is the fundamental difference between those three types of VPCs? How firewall works? And what are the different rules in the firewall? Whether I can expand my VPC, whether I can add additional subnets to my VPC. That's what you need to know at this moment. Is everyone with me on this?
Yes, sir. I have a question. Like, if we are not configuring routes, how it will
Mhm.
connect to the internet?
No, it is already configured. Routes are by default configured. That's what I'm trying to say. So for example, we have a subnet in Asia Pacific South 1, right? So we'll go to
US
Asia
Eastern.
Pacific South 1 here, Mumbai. and click on view routes, and you will see the routes here. It already has routes configured. You can see all routes are configured. So what are these routes? You can see here. It says if the destination is 2.0, 3.0 or 1.0, it is locally available. It also says if the destination is 10.1. It is locally available. But if the destination is internet, then your priority is this and go to default gateway that knows where internet is. But if your destination is this, you don't need to go anywhere. It is available within this virtual network. It is available as part of this VPC only. So routes are already configured based on how you provision your VPC. If you provision an auto mode VPC, it will configure route for each region. If you provision a custom mode VPC, then routes will only be configured for the region where VPC is configured, where subnets are configured basically. So it has routes here. And because of these routes, the communication will work. Make sense?
Yes, yes. I think it is a mixture of AWS and Azure.
Yep, that's the reason I'm saying to, to understand this cloud, don't compare and correlate. Compare and correlate when you have understood the services. If you try to compare and correlate while trying to understand the service, you will unnecessarily stress yourself. And nobody is asking you this question that, okay, how it is different or similar to AWS and Azure. Nobody's asking. Even your customer will not ask you. This is just your internal knowledge. When you call yourself a multi-cloud person, that is where you will be expected to know the difference and similarity. But you're not a multi-cloud person as we speak. You're learning GCP, focus on GCP. I am explaining the similarities and difference because I feel that I should be explaining, or whenever I feel that I should be explaining, I'm explaining it. But I will also not do it for each and every service. Otherwise, you will get confused. However, if you ask me question, I can always answer. For example, Madan has asked whether it is similar to this or different. That's where I answered the question.
Sir, that time Madan asked one more question that what about the subnet allocation in cloud,
Hmm.
the first 5 subnet will be going for the like one is gateway and some networking. Like I
Hmm.
forgot,
Hmm.
first 5 subnet will be reserved.
Yeah,
Like in GCP, it is the same.
that's what you need to find out as an assignment. I'll answer this
Okay.
question tomorrow, but I want you
Okay.
to find the answer of this question. How do you find the answer of this question? By provisioning a resource, by looking at the IP address of that resource, and you will quickly know. So for example, if I go to the subnet, which is, let's say this subnet, the first subnet that I provisioned in Asia, the first subnet that I provisioned in US, 192.168.1.0/24. When you provision the first resource in this subnet, if you find the IP address of that resource as .4, it means it is reserving first 4 and last IP. Last IP is any which way is reserved. One thing is for sure that last IP is reserved. You need to find out whether first 4 IPs are reserved or only one IP or only the first IP is reserved. That's what you're trying to figure out, right?
Okay.
That's what you need to figure out yourself by provisioning a resource, and you will get the answer of this question.
Yes.
Make sense?
Yes. Yes.
Great.
And the
So yeah,
dynamic allocation or the custom like one by one IP will be happening.
that's what you will figure out when you
Okay.
provision the second resource. If the
Okay.
second
Okay.
resource gets 5, then that's its sequential provisioning. If
Oh,
second resource gets 20, then it's dynamic provisioning, right? So the question is,
yes.
are the IP addresses inside a subnet allocated dynamically or they are allocated sequentially? That's the question. Find out the answer yourself.
Okay. Okay.
If I say yes, you will forget by tomorrow. But if you do it and find it yourself, you will remember forever. Yep. Come out of
Okay.
college, guys, and try to learn things by yourself and leverage the trainer for questions. Rather, depending on trainer to teach you everything. That's not the agenda of this training at all. The agenda is to introduce Google Cloud. and specific services in Google Cloud so that you guys are prepared for the support or for the projects which are, which are almost at the verge of getting introduced very soon. That's the agenda of this training. All right. So that's about the custom VPC or 3 types of VPCs that we have in Google Cloud. Now, what I want you to do, guys, I want you to provision. Let's provision the VPC first, a custom VPC, then provision the first resource, first machine in the VPC. I leave the decision to you whether you want to provision a Linux instance or a Windows instance, depending on what you are more proficient with. If it is Windows or Linux, provision an instance and find out whether the firewall configuration that you have enabled, they are applicable or not. They're actually working or not. That's what you need to figure out. So all of you navigate to your hands, lab environment and then do it and show it to me. Provision an auto mode VPC with default configuration. Provision a custom mode VPC with custom configuration. Provision a resource. When I say resource, it's compute engine. We can say Google Compute Engine. Provision a resource or VM and validate functioning of firewall rules. Also, the answer. Answer to the question of IP address allocation from DHCP, whether it is dynamic or sequential. That's what you need to figure out. Right? So I'll give you 10 minutes to do this, and I'm open to questions if you have any while trying to do this.
Hello. Hello.
Yes, Rakesh, tell me.
Yes, everything is done. I checked
Done?
everything.
What did you find?
The IP address allocation, it is not dynamic, it is static, like one by one. And
Okay.
like parallel rules, I'm able to it is able to communicate via private IP address. I checked. Like
It
a
is able to
ping
communicate via what?
private IP address. Like I log into one server, I pinged the another IP from another VM, like private IP from this server. So it is able to pinging.
Okay, so first thing first, can you show your
Yeah.
screen and explain it to rest of the participants?
Yes, these three are I created. See,
3
ES is
machines you
one.
created. Okay.
It is in US is one. See, this US is one, and okay, let me show you the
Okay.
configuration. It is Ubuntu only.
So the
Okay.
answer to one question is right there on the screen. Look at the IP address. 1.1 is the gateway IP address and 1.2 is your machine is getting. What does that mean? That Google doesn't reserve 5 IPs.
Only
Right?
one IP.
Only one IP Google is reserving, which is the 1.1, which is the gateway address. And it starts to give you from the next, which is 1.2. Then the same VM. Then there is another VM in the same zone or in the same network, subnetwork that is getting 1.3. So what does that imply? That implies that the IP address allocation by DHCP is sequential. So 1.2, 1.3, 1.4. Let's say you delete 1.2. Now the next VM that you will create that will not get 1.5. It will get 1.2. It will fill up the empty spaces and then move on to give additional IPs. Make sense? So that answers the question that yes, the IP address allocation is, is sequential. Second, it doesn't reserve 5 IPs. It only reserves 2 IPs. The first one and the last one. Badal, did you get answer to your question now?
Yeah, got it.
Great.
Right.
All right. That's the reason I wanted you to do and understand it by yourself, because then you would remember it forever. If I had told you the answer then and there, you probably would have forgotten it. Now you've seen it, you will remember it. Okay, next. Over to you, Rakesh.
Next, yeah. Next, I connected using this VM using SSH. Then if I want to check all the VM are communicating between each other, so I pinged from this VM to this VM using this IP
Why don't you
address.
show it? Show it to the participants.
Yeah. See, I pinged this too. Again, I'm pinging.
Okay, before that, how did you connect? The connectivity part also. Just close this
Connectivity.
connection.
I connected using Cloud Serve, this one.
You clicked on SSH.
Yeah.
Then
Then it prompts me to authorize. So it will be transferring SSH key in the backend.
So it's a browser-based SSH connection that you are doing.
Yeah.
Right. So you can see that it's opening the connection on a browser window. It's a browser-based SSH, which does not require you to use solutions like PuTTY, WinSCP, third-party solutions to SSH into your Linux instances.
No.
Okay.
Then
All right,
I'm
then.
just pinging the private IP of this. Just ping the Linux 2 machine. It is 2.2. 2.2. See, I'm able to ping via private IP.
Yeah, so which basically means that all the virtual machines inside a network, inside a VPC, irrespective of their subnetworks, they can communicate over internal IPs, right? Now
Yes.
let's just go to the firewall rule for a moment. Go to the firewall rule and look for that rule which is enabling this communication, the custom rule. No, scroll it to the left, you will see the custom rule. There is a rule which says custom, which has all the IP
Yeah, these are
addresses.
the, yeah.
Is this the one? Expanded? You have many. No. So you need to, if this is how you will go, it will take you to the common firewall and you will see all the firewall rules. Don't go like this. Go to your VPC.
Okay.
Navigate to your VPC. Select your VPC. Now click on firewalls. It will only show the firewall rules of this VPC. Okay. Now click on the custom one.
Yeah, this one.
Custom. Yep. So this is the rule which is actually allowing this communication, right? Because of this rule, it is working. So what we can do, we can just change the configuration of this rule and make it deny. Instead of allow, we can put it deny. Go up, click on edit, and the action should be denied. There's an option to deny, right? Action on match, allow.
We are
Scroll
not
it
able to
down.
change.
Scroll it down. Allow all specified port and protocols. Click on specified disable rule. You have disable rule.
Okay.
Disable. That's it. Okay. So your rule is disabled. Now go back to the instance and try and ping once again. You will see that it will now deny. Not so quickly. I will say wait for that rule to just go back and check whether that rule is disabled or not.
Okay. So
Go back to the firewall rules once again. Scroll to the right.
It is still allowed. No. This one.
No problem. Let's create another rule. Let's create another rule to deny that communication, right? That way we
Okay,
can change.
priority will be less. Yeah. Okay.
Create another rule. Create firewall rule. Yep. Yep, that's you did the right.
Here on.
Okay, now put the name. Deny. Okay. Scroll it down. Priority is okay. Priority is okay. Whatever you put, it has to be less than 65,000. That's okay. Direction of traffic is ingress. Action on match is deny. Now specified, not target text, IP address, all instances in the network, let's say. No, if you see all instances, then you will also lose access to your remote. Don't say all instances. Specified targets. No, not the tags. No, not this one. Just leave that part.
Okay.
Just don't select anything.
Let's see. I think we need to click. If I click
all instances. Okay, that's okay. All instances. That's okay. Click on all, scroll it down. Source filter, IP edges. Source IP range is now put the source IP range. The IP range of the VM that you are on right now. You are on this VM, right? Okay, great. Destination filter you don't need to put.
Okay, let me change my IP.
Do we need to put /32? Not required.
That's not required.
Okay, I need to check the IPs. I think
No.
it is the IP now.
Which, no, understand this. There are two things. You actually, okay, go back. Don't create route like this. Go back. Go back, and the way I say, then do it. Go back to the create firewall rule once again.
Yes.
Okay. Now select deny communication, scroll it down, custom VPC, scroll it down, specify target text, leave it that like that. Deny, action on match is deny. Scroll it down, source IP ranges, source you can source you don't need to put source, put internet. No, but you are doing internal communication, right? Source put the IP address range of your of the VM.
Yeah.
Right? That VM, go back, open another tab, click on compute engine. Are all of these VMs? Yep. So 1.2, right? So that's the source IP. You get put this IP. Yeah. That's it. Deny all. That's it. Create this rule now. Scroll down. Okay, it is requiring the tag basically. Okay, all instances in the network you can say. Yeah. So when you create a firewall rule, it will take, sometimes the rule is applicable the next moment. Sometimes it takes a couple of minutes to get replicated also. See, it's not pinging now.
Yeah.
Yep. So this is because of the rule that it is not pinging. Now that you have created a rule to deny all communication, right? All communication, and you mentioned that to deny all the communication to that IP, that's the reason the rule is not pinging now. So that's the concept of firewall rule. Make sense?
Yes.
Great. So that is all, guys, for today. We will do some more, lab tomorrow.